Hey, it's Mr. J here. We're talking about fractions today. So there's a few different types of fractions, but generally what you're looking at in a fraction is you're going to have, some number on the top. We call that the numerator, and then on the bottom we have a Dementor from Harry Potter. No, we've got a denominator. Okay, and a denominator and a numerator, and then you've got the line in the middle. Now, I like to always try to refer to the line as out of. And what I mean by that is I try, and I don't always succeed. I'm sure in this video you'll catch me a couple times not doing it. But I like to say 3 out of 4. Now this is a very common fraction. Usually people call that 3/4, so that, like this most people would call half, right? But when you get into some sort of stranger fractions, maybe like that, well, I mean, it's 2/12, but usually I would try to say 2 out of 12. Okay, and the reason I do that is because I want kids to think of fractions as that way, right? So when we see a number like, I don't know, 5/7 or 5 out of 7, a lot of people say 5 over 7, but I try to say 5 out of 7 because that's basically what a fraction is, right? When you're in younger grades and you're working on numbers, you're working generally on, regular numbers. We call these whole numbers, okay? So 3, 12, 736, 1,296,326, whatever your number is, it's a whole number. And what they mean by that is that it's sort of complete, it's full, right? If I'm out in my, trying to build something in my backyard, I'm looking for bricks, and I've got some old bricks from a patio, and I start pulling bricks out, right? And I start making a little place to sit, let's say, and I start putting my bricks out. And as I add them, I count them up. So I've got 1, 2, 3, 4, 5, 6 bricks, right? I have 6 bricks, and those are whole bricks. They're whole numbers. They're complete bricks. But then I'm looking and I see like something sticking out of the mud, and I pull it up, and it's, a half brick. So it's not complete. It's not a whole brick, all right? And so we would need to represent that some other way. And there's lots of ways, but today we're talking about fractions, okay? So basically, when I teach this, I try to talk about parts and wholes, okay? So parts and wholes. And wholes just means the whole numbers, the regular numbers that we're used to working with. And then parts refers to anything that's not quite complete. It's not a full number, okay? And so in this case, we're talking about fractions, all right? So the next question is, how do you show a fraction? How do you represent a fraction? I mean, you write it, right? This is how you would write a fraction. You would include the numerator in the top and the denominator in the bottom. And the denominator tells you how many you need until it's full, okay? So for example, in our brick situation, if that's my brick, if that's a whole brick, right? Then this is the half brick. And the reason we write it as a 1 with the line and the 2 is because we would need 2 of them to make the whole. Right? If we had that second half of the brick, that second part of the brick, we would have the whole brick. So we need 2 of them to make the whole. But we don't have 2. How many do we have? 1. Okay, so we have 1 out of the 2 pieces we need. Okay, so that's why I like to say 1 out of 2, right? We need 2 pieces to make the whole. We've only got 1. We've got 1 out of 2. Okay? If the brick piece was even smaller that we found, let's say it was that big, then we would use a different fraction to represent it. And in that case, it looks to be, we still have 1 piece, right? Out of, we need 1, 2, 3. So that fraction we would call 1 out of 3, or 1/3. We have 1/3 of the brick. Okay? So that's how you write a fraction. But now how are we going to show it? How are we going to show what it looks like? Well, I mean, I kind of did some examples here, but there's other ways. So if you asked a kid, like if I got a class of grade 4s or whatever, and I showed them like a very sort of common fraction, 1 out of 4, or 1/4, or 1/4. If I said, show me what that looks like in a picture, like represent it in some way, I think that almost all the kids, in fact I know because I've done this, most kids would draw a circle, they cut it into 4 parts, and they would take another color, or they'd shade or whatever, and they would fill in their quarter, or their 1 out of 4. Okay, that's awesome. There's absolutely nothing wrong with that. It's fantastic. It's totally correct, right? I mean, I didn't measure it. It's not perfect, but there's 4 equal equal. There's 4 equal parts of this circle, and we have taken one of those 4. If we had all 4, it would be full, right? But it's not. We don't have a whole circle. We've got 1/4, 1 out of 4, all right? Cool. Now here's the problem. You get into a fraction like, let's say 3/10, 3 out of 10. Well, this is my problem with circles. And if you are an excellent artist and you're perfectly capable of measuring things and you got your compass out, then I mean, there's nothing wrong with circles. But for me, I find it very difficult to fill them in. So now if I need to make 10, like I'm not exactly sure, I'm going to try for 1, 2, 3, 4, that's eighths. So you can see my problem is that I have a very hard time splitting circles into even parts. It's easy when it's, you know, half or quarters or something, but even tenths, it's very hard. And what if you had a fraction like 7/13 or something? Like, I have no idea how to split a circle up that way, okay? So for that reason, I don't use circles. But if you can figure it out, I mean, you're smarter than me. You're better at art than me, certainly. I use a rectangle. Okay, so I always use just like a little square, a little rectangle. It doesn't have to be perfect, and if I want to represent a quarter, I can split my into a little window there and fill in my quarter really fast, okay? And then if I need to do, so there's my 1/4, 1 out of 4, and if I wanted to do, what was my other fraction there, 3/10. So if I want to show 3/10 as a fraction, again, I'm going to split this into 10 parts. So I'm going to split it into half first, and then I'm going to add 4 lines, 1, 2, 3, 4, because that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts, okay? And then I can represent 3/10 by filling in 3 of these. I usually start filling at the top. I don't know why, and I kind of go like the way you read, but you know, I could have filled in this one, this one, and this one. I could have just filled in 3 random boxes, and it would still be accurate, right? It doesn't have to be like 3 in order or anything like that. But there you go. So there's a quarter, and 3/10 represented that way, okay? Now, that's 3 ways we've shown. So we've got sort of just the fraction written as a number here with the numerator denominator. We've shown circles and why they're good and why they're maybe not as good for other parts. I showed you my box method, which is my personal favorite. And at the end of this, I'll show you why it's really great for comparing fractions. So stay tuned for that. Probably the best way, really, to show a fraction is on a number line. So here's my number line, and I'm making it from 0 to 1, okay? And I'm doing that for a reason, and I'll tell you why in a second. But let's represent a couple fractions. So let's stick with a quarter, and let's do 2/3, okay? 2 out of 3. So we're going to put those fractions onto number lines, okay? Or onto number lines. So here's my 0 to 1. So I'm going to represent 1 out of 4 first, 1/4. So here's my number line, and I'm going to split it into 4 parts because I'm doing 1 out of 4, okay? So here's my 4 parts. So if I filled up to there, that would be 1 out of 4 because it would be 1, 2, 3, 4 until it's full. 2 out of 4, which is the same as a half, 3 out of 4. And then finally, my one whole would be the 4 out of 4, right? So to show 1/4 on there, I would just fill up 1 out of the 4, right? If I had filled up 2, 3, 4 out of the 4, it'd be full, but I'm not. Okay, now I want to show 2/3. Is 2/3 bigger or less than 1/4? Well, let's find out. So in this case, 3 is my denominator, so I need 3 parts before I have my whole. So I'm going to split this up into 3 parts, okay? And I'm just sort of, you know, doing this by eye. I'm not being perfect here. But if I want to be perfect, I could use a ruler and I can measure my line and split it up more evenly, right? But 2/3 I can see, there's 1/3 and there's 2/3. Oops, I went a little too far. But you get the idea, okay? So 2/3 is quite a bit bigger than 1/4. And there's my proof, right? And it makes sense, right? If I'm collecting something, if I'm collecting Pokemon cards and I'm trying to get 3 Pokemon cards to complete a certain collection, and I've got 2 Pokemon cards, well then I'm pretty close to finishing my whole collection. Whereas if I'm trying to collect 4 Pokemon cards and I've only got 1, I'm quite a long way from being done. Okay? So there you go. Now, the reason I wanted to do my number line from 0 to 1 is a specific reason, because there are 3 types of fractions. Okay, so there's proper fractions, There's improper fractions who are rude to their grandmothers, and there are mixed numbers. So these are like the three sort of fraction types that you deal with in school. So proper fractions are any fraction where the numerator is smaller than the denominator. In other words, you're not full. You're not at a whole number, okay? So 1 over 4 is a proper fraction because it's smaller than 1 whole, right? Which brings us to improper fractions. So I'm going to, whoa, my table is wobbly. So an improper fraction, I'm going to stay with an out of 4 fraction. If I put a 6 on top of there, then that is what they call an improper fraction because it is more than a whole, right? If I need 4 to complete my Pokemon collection and I've got 6, then I've got my whole collection plus. I got more, okay? And then mixed numbers are fractions where you have a whole number and a fraction beside it. Okay, so like 2 and 1/4, or 1 out of 4. So that would be a mixed number, okay? We're mostly looking at proper fractions today, and every single proper fraction, all of them, exist between 0 and 1. There is no such thing as a proper fraction that is smaller than nothing and that is bigger than 1 whole. If it's bigger than 1 whole, it's either an improper fraction or a mixed number. It can't be a proper fraction, okay? And there's an infinite number of fractions that exist in there, right? 1/4 would be about there, you know? But there's a fraction that exists right, you know, right before 1. And it's some crazy fraction, you know, like if I said 999 out of 1,000, it would be, you know, just slightly less than 1 whole, right? Imagine you need 1,000, you know, pieces of wood to build a deck. You've got 999 pieces of wood. Well, you're like almost there. You can almost build your deck, but there's going to be something wrong with it because you're missing that one piece, right? So that would be an example of a fraction that's, you know, almost whole, but it's still a proper fraction because it's not quite 1 yet, okay? So there you go. Okay, I want to look next about ordering. So in math class, you'll often be asked to order fractions, right? Which literally just means put them in order, okay? And that should always mean from least to greatest. Or from smallest to biggest, in other words. Now, some teachers, if they're not very nice, might ask you to go greatest to least, but that's really just being mean because that's not the way people order things, okay? People order things in order from least to greatest. So if I asked you to say the alphabet, you wouldn't start at Z and start going backwards, you'd start at A. You go A, B, C, D, E, right? You work from the start to the end. If I asked you to count, you wouldn't start counting at 1,000,000 and work your way backwards. You would start at 0 or 1 and work your way up, okay? So hopefully your teachers will be kind and ask you to order always from least to greatest, but that's generally what happens, all right? So here I'm going to have 2 fractions. So let's go half, and let's go with, I don't know, 3/4, okay? So if I asked you to put those 2, well, let's put a whole number in there. Let's put 1 there. Okay, so if I asked you to put those in order from least to greatest, you would need some way to compare them, okay? So I recommend using the box, or a number line, but you can use whatever system you sort of think is best. But if you're not sure, try mine. So I'm going to represent these 3 fractions in my boxes. So 1 out of 2, or 1/2. I'm going to split it this way this time. And I'm going to fill in my half. Okay, so 1 out of 2. There you do. Next one is quarters. And I'm going to split it. I could split it the window way, but this time I'm going to split it just like this, okay? Horizontally, I guess, because I want to show how 3 out of 4, 3/4, how that compares to half, how it is quite actually a bit bigger than a half, okay? And that shows it. If I'd split it in the window way, it wouldn't maybe have been as clear. And then 1, it's full. Okay, it's the whole thing, right? 1 whole, so the whole box is full. So if I had to put those in order, it's actually really easy because I actually wrote them in order, okay? And they're there in order because 1/2 was the smallest number here, 3/4 is in the middle, and 1 whole, not surprisingly, was the biggest, okay? So that's one way. I also could have used the number line though. So if I build my number line from 0 to 1, all right, it becomes pretty clear. If I need to make 1/2, it would be right here. And if I needed to make 3/4, I need to split it into quarters. So 1, 2, 3, 4 parts. And this would be 3/4. And then 1 whole would be right there. Okay, that worked out really easy because they all fit nicely onto the number line. But I could have used multiple number lines as well. So there's my half, and there's my 3/4, and then there's my whole. All right? So you can use multiple number lines. I only needed one, but I could have just as easily drawn a second number line on the bottom. And as long as they are the same length, then you're okay, right? And I'm just sort of freehand drawing these because they're far enough apart that I can see the difference. But you could use a ruler, right? I could have used a ruler and measured out, let's say 4 centimeters, because that was my biggest denominator, and then measured out to make sure that I was, perfectly accurate. But I'm going to show you one other way. This is my personal favorite way. I draw one box. Okay, and then this will work well for comparing two fractions. I can't do sort of all three at once, but I'm just going to compare 1/2 versus 3/4. Okay, and I'm going to do it in one box. And the way I'm going to do that is I'm going to split the box one way first. Okay, so that's my halves. So I've split the box into halves. And now, so I did that vertically, up and down. Now I'm going to take, so there's my halves. Now I'm going to take my quarters, my out of 4s, and I'm going to split it horizontally. So I'm going to go 1, 2, 3 lines, because that gives me, 1, 2, 3, 4 parts. Okay, and now I know there's 8 in total, but I'm really thinking about halves this way. So 1/2, 2 halves, and then quarters this way. 1/4, 2/4, 3/4, 4/4. Okay, and now I can sort of compare them on the same sort of box here. Because what I'm going to do is I'm going to fill out 1 out of every 2 boxes I'm going to fill out. So 1 empty, 2 full. Okay, and I'll do those red there. 1 empty, 2 full. 1 empty, 2 full. 1 empty, 2 full. So I filled 1 out of every 2 boxes. Now I'm going to take a different color. Let's go with the green. And I'm going to fill out 3 of every 4 boxes. So I'm going to fill out 1, 2, 3, and I leave 1 empty. And then 1, 2, 3, leave 1 empty. And I can see by the time I'm done that the 3/4 was bigger than the half. How do I know for sure? Well, the half took 1, 2, 3, 4 boxes, and the quarters took 1, 2, 3, 4, 5, 6 boxes. So it's bigger. It is larger than 1/2. Okay? And I can sort of like keep track of this. So it took 6 boxes out of 8 boxes to do my 3/4. And to do my half, I did 1, 2, 3, 4 boxes out of 8 boxes. Okay? It's a little complicated, but if you do this a few times, it'll very quickly tell you which one's bigger. Which one's bigger? Well, the one that was 6 is bigger than the one that was 4 because they're the same, they're both out of 8, right? So it makes sense that 3/4 is bigger than 1/2. This brings us to our last thing that I really wanted to talk about, which is something called equivalent fractions. And we just sort of did that right here, okay? So what's an equivalent fraction to 1/2? 4/8. And what does that mean? It means they're the same sort of amount towards full, okay? Which is a weird way of saying it, but hang with me, dude and dudettes. So if I've got my number line, and I'm just going to put 1/2 on there, there's 1/2, right? There's 2 parts until we're full, and we've got 1 of those parts. So we're 1 out of 2 on our way to being whole, okay? 4/8, if I put it on the same number line, so in this case I need to split it up into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 parts, okay? And 4, I need 4 of them. 1, 2, 3, 4/8. Okay, so 4/8 is equivalent to 1/2 because it's the same amount of the way to being full. Okay, it's not the same fraction. Some kids will say it's the same fraction. They're different, right? If this is a story where I need, I'm trying to collect old cars and I need 2 of them to finish my collection, and I've got 1 of those 2 cars. First of all, I've got too much money and I should probably spend it on something better, but I'm halfway there. I'm 1 out of 2 ways to my collection. That might be that story. 4/8, maybe I'm collecting video game systems and I have 8 of the systems I want, or sorry, I want 8 systems, but I've only got 4 of them, so I'm 4/8. So they're different fractions, they're different stories, but they both represent an equivalent amount towards full, okay? So that's what an equivalent fraction is. What's an equivalent fraction to 3/4? 6/8, okay? And we proved it inside this little box here. So I think that's all the things I wanted to talk about. I know it's kind of a lot, but basically the whole idea with fractions is usually we're looking at proper fractions, and those are fractions that are not whole. They're less than whole, greater than 0, okay? So let's go back and look at the things we talked about really quick as a quick review. We talked about whole numbers and then how fractions are a little bit different than them, how they represent parts instead of being a whole complete number. We talked about the numerator being the number on top and the denominator being the number on the bottom. We talked about using that line to say out of, to know that we need 4 to be whole, and we've got 3 out of those 4 parts. Okay, we talked about bricks quite a bit, as I like to do. Okay, we looked at different ways to represent fractions. We talked about circles and how they're perfectly fine, right? If you've got a computer to make your fraction circles, awesome. They're going to be perfect every time. But for me, at least, I have trouble with strange number fractions that aren't like really easy to represent in a circle. I have trouble drawing that, but I also have, you know, handwriting like a tiny child. So there's that. But I prefer using either a fraction, we can call it a fraction square, but sometimes it ends up being a rectangle, or I should say, number lines. Okay, those are, for me, the best way to represent fractions, especially when I have to compare fractions, all right? We also talked about the 3 sort of types of fractions: proper, which is any fraction less than whole, less than 1 whole. Improper fractions are bigger than 1, so that means the numerator would be bigger than the denominator. I have more than what I need to get to 1 whole. And then mixed numbers are numbers where you have whole numbers mixed with fractions, hence mixed numbers, okay? And then we talked about equivalent fractions a bit, and I showed you a couple ways that you could compare fractions if you need to put them in order. You could use boxes, okay? The problem with boxes is if you get 2 fractions that are very close to the same size, then it can be hard to see with the boxes, which is where a number line or number lines might come in handy. And if you get fractions that are very close together, you might need to actually use a ruler or grid paper to make your number line and then measure them that way. Okay, and then finally, I showed you what I think is the most complicated way to compare fractions, but it's also the best, because all you have to be able to do is count. And that's when you compare 2 fractions, you split a box into the denominator. So in this case, I split it into 2 parts, right? 1 part on this side, 1 part on this side. And then since the other denominator was 4, I split it up into 4 boxes this way. And then I was able to just fill in 1 out of 2 boxes in the orange, and then 3 out of 4 boxes with the green. And that's how I was finally able to compare those 2 fractions by saying, well, if they are both out of 8 now, if I made equivalent fractions, I can see that 6/8 is bigger than 4/8, therefore 3/4 is bigger than half. There's my proof. Okay? We also talked a little bit more about equivalent fractions and how we could see them on a number line as well. All right, and if I split this up, let's just do it since we're here. If I split this up, you know, into a million, well, let's go 100. Let's say I split this up into 100 parts, which I did not, but let's just pretend I did. Then how many parts of those 100 would I have filled out? It would be 50, right? Because I'd be halfway to my 1 whole. Okay? So hopefully that's some helpful information and some different ways of visualizing and seeing fractions and then thinking about different ways to compare them. And I promise you, if you start using like a method like this, for example, when you're in a grade 4, 5, 6, it's going to be very helpful when you get into older grades. I've taught grade 8 math, and kids who come in with a good understanding of fractions and how to show them and how to compare them do very well when we have to multiply fractions or use fractions in algebra or things like that. And the kids who don't have a good grasp of the fractions, you know, it's a little more work for them. They got to catch up because they don't have that sort of visual understanding of the numbers. So that's what I'm trying to show you here. So I hope you enjoyed it. I hope you found it useful, and see you soon. Bye.